I am going to introduce our guest speaker today, Noel Gomez. He's the co-founder of Datacoves. Noel, welcome to the community call.
Yeah, thanks.
Awesome. So today, Noel is going to give us a rundown on how Datacoves have integrated Airbyte into their analytics workbench. It's a really cool product. We saw it beforehand, and I would love for Noel to take the wheel on this call and show our community and everyone a part of this stream right now and on YouTube later on, how this looks and how it works.
Great, thanks. I'm happy to be here. Thanks everybody for attending. Yeah, today I'm going to go over Datacoves and how Airbyte and other tools are integrated. We really see an opportunity to make the modern data stack a simpler experience for people. And I've been very excited about Airbyte from the first time I saw it, and I see a lot of potential, and I can see how we can help the community. All right, as we said, we're looking at Datacoves as being the fast track to the modern data stack. When companies and individuals are trying to figure out their way around the modern data stack, there's so many decisions to be made, tooling, all the infrastructure, the processes, there's many things to be figured out. And what we're doing is really taking all the different pieces, connecting them together, creating a process, and suggesting best practices. It's an opinionated way to do modern analytics. So what do we see as the problem is, I'm sure most people have seen charts like this before. There's a lot of fragmentation in the modern data stack. There's a lot of tooling to be figured out, a lot of processes to be figured out, and it's overwhelming. So if you're coming from a traditional legacy tool where everything was integrated, now you have to figure out how are you going to load data, how are you going to transform data, on and on, many decisions. And a lot of the times people they don't even know what they don't know, what questions to ask, etc. We think we can improve that. So what happens today, it's starting up the whole platform takes a long time. And that's because there's hundreds of tools to choose from. There's a lack of integration across the tools. So you have to think about, how do you trigger a process? How do you orchestrate the whole thing? How do you do linting? On and on. There's many decisions to be made. And so that makes it harder for people to do this stuff. And then architecting that whole platform in a secure way. How do you do EL when you have sensitive and PII type of data? Thinking about all of that stuff takes time and takes experience and know-how in, for example, if you're using Snowflake, how do you do this well? How do you structure your groups, etc.? And finally, you need to implement best practices. You want to create something that will scale over time. So even if you're starting with a team of 5 people, when you get to 50 people, how do the processes that you started out with, how do they scale over time? We take all of our experience and put it together into the tooling and this opinionated way of doing analytics. So what we're doing is really taking all of the open standards and tools and build reusable formulas of best practices to do analytics. And our goal is really to have an end-to-end turnkey data stack. We manage all the infrastructure. We have it pre-configured with dbt, which we believe is the best tool for transformation. And finally, we integrate the best practices. So enough slides. Let's go and look at a demo. All right, so this is the data set that we're going to be working with, just so that we set the context and everybody's aligned on what we're doing. It's consumer price index information. And we're going to look at gas prices because we're all dealing with gasoline, high gasoline prices. The way that this is broken out, it's a consumer price index. So there's all these different items. For our purposes, we're going to look at this one. So regular unleaded gasoline. And the data set that we're going to pull looks like this. It has different types of gasolines over the years, and it gives you the price essentially. All right, so now that we have that out of the way, that's our data set. Let's look at how we do this end to end. So as I said, we're going to go through this process where we're going to load the data. We're going to transform the data. We have here the GitHub Actions and documentation. We won't go into the GitHub Actions too much, but it's the whole CI/CD data ops processes that go along with that. How we run Airflow and integrate those first 2 steps. And finally, how we use Superset to visualize all of that. So let's get started. So the first step here would be in Airbyte. We want to add a source. So let me go copy the link of that data set we were looking at. Okay, so anyone who has done with anything with Airbyte will know how simple this is. I select that I want to source here. I want to call it CPI gasoline. There's the URL for that file. And then I'm going to use the same name for the data set. And in this case, I need to give it reader options because this data is actually tab delimited. So you do that this way. And that's all I have to do. So this is validating that data source. It's good. Now I need to connect it to my destination. I already have Snowflake set up as my destination. Now, when we get to this step, we can schedule things with Airbyte just like any other any other way. But we actually prefer to not schedule it with Airbyte because we will do this with Airflow later. Another thing that we do is we have this convention of giving it a custom schema. So that name that I have, that's CPI gasoline. So one of the best practices that we follow is every source will get its own schema. And that's how we actually we protect the data. So we can say one user gets access to this raw data while another user does not. And so we segregate things by these data sources. Another thing that we do is we do not normalize the data here. We leave it as raw and we will normalize it later. We will flatten it later with dbt. So that's all I need to do here. So now that we have this, we can launch the process. Okay, so we start the load. So while this is loading, it should load pretty quickly. But let me just show you what's going on over here. When we load the data, we use this loader Airbyte role. And you can see loader Airbyte doesn't have much access. And what we see here is that this is what I was saying. Salesforce data would go here. That CPI gasoline goes here. And there's the load process. So this should be done pretty quickly here. Oh, I think I had loaded this before without the CPI. But this is the new data. So now if I confused myself. So if I preview the data here, I need to select a warehouse. There we go. So this is how Airbyte loaded the data. And you can see it's just the way that it came in. Another interesting thing to note right here is that for whatever reason, these names have extra spaces in the name. We'll see how this comes into play. And actually, a bigger problem is this one right here. So the value has extra spaces at the end. That took me a couple of seconds there to figure out why something wasn't filtering. But so the data's loaded. And like I said, we do this with a single role. Our best practice is also to say, when you load the data, only Airbyte can essentially read this. There would be a secondary step where you're granting access. That would protect, again, if you have sensitive data, PII type of stuff, we would have a secondary step that then grants a specific role access to that new schema, right? So now that it's loaded, let me just check my notes here. We can look at transform. So now that the data is loaded, we're going to go and transform. So here we have a full Visual Studio Code environment. And
that is pretty cool, though, the fact that you just use it all there within the browser.
Exactly. Yeah, there's nothing to install. These are all containers running in Kubernetes. So if we wanted to add a new user, I just need to invite that user and they get the same environment, same version of Python, dbt, and other dependencies that we have on here. So there's nothing to install. Now, another thing here, talking about best practices, is how we organize this. So if we think about a traditional project, they get a database and they figure out like how they're going to load the data, how they're going to transform the data. And they may think about dbt, and let's say they're using dbt. And so they'll create the dbt project, but that's just handling this stuff right here. We know that there's more things to be done in a real modern data stack and in a real repository. So we put dbt one level down, and then we think about all the other things that you need to do. So here, for example, we have GitHub Actions. So these are the workflows that we would run under CI/CD. We have automation scripts. So here, for example, we have a script for a blue-green deployment in Snowflake. Here's where we would back up all of the connections, things from Airbyte. So instead of, even though you loaded it via the GUI in the load tab, we would want this to be in the repository and then have a process for deploying this in higher level environments, say dev to test to prod. Here, we actually are going to, I'll talk about this a little later, but this is how we create the DAG for Airflow. And then here is where we actually do the roles that I was mentioning. So all the security. So the point is a modern data stack and if you want to do everything as code, there's a lot of components to be figured out. And like I said, we're giving you an opinionated approach. You don't need to follow all of this to use Datacoves, but here it is. You don't have to think about all of this stuff. So now that we have loaded that data, the first thing that you need to do with dbt is register it as a source. So just like I had different schemas over there, we would do the same thing over here, have different folders per source. And the first thing that we want to do is tell dbt that this source exists. So how we do that is normally in dbt, you would write out the YAML and the SQL file that connect to that source and then flatten it. But we know a lot of stuff. So why don't we just query Snowflake directly? And through this library, dbtcodes generate sources. We can point it at that schema that I did over there. And here, I don't want that second one. I want this first one is the one that I loaded. And I'm going to say, I want that. It recognizes that there's a JSON field on there. So now based on this, it will generate these two files for me. So without me having to do a lot of work, I'm already getting the starting point. And remember all those spaces? Here they are. It already figured that out for us. Less work.
Nice.
And we know we want to do other things here. So one thing that we may want to do is trim those spaces, because I mentioned how the values have that, right? So I can do, let me just do it this way. So I want to do a trim and here. So now make sure I get rid of all the spaces within the values. I want to change this one to price. This is not a varchar. So by the way, if you knew a lot of them were in varchar, you could just select a bunch of them and do multi-cursor integer. In this case, I don't want that. So I just want this one to be numeric. 5.2, and then year, this should be integer. Okay, so now let's see what does that look like so far. So now this is compiling that code, submitting it to Snowflake, and that's what this looks like currently. Now I know that I can't graph this, so I'm going to create another column. Let me just copy this. And I don't need that stuff there. Okay, so there. So now I have this, and let's see if this refreshes. I'll close this one. And by the way, another advantage of this, when this comes back here, is that we're going to give you a sample of the data. That's what we're doing now. But we can actually see in a second here the actual query. So we can take the query from here and put it into Snowflake directly if you wanted to do further analysis. Hold on, I must have done something wrong here. Let's do it again.
There's no such thing as a demo without bugs during a live presentation.
Yeah, something is taking its time.
Always happens.
The first time it did it right. Okay, well, trust me, this actually should have returned the data set. I'll do one last thing here, reload the page entirely, see if something. Okay, so while this is working, if it works, this model, I'm doing a previous, compiling it, it's submitting it, but it's not actually materializing it. It's not yet created. So let's see if this works. So if I click that, we should get the model to compile. So this is essentially going to do my DBT run. I'll close that. I don't know what happened.
So restarting it fixed it.
There we go. Okay, so now this materialized, created that model. Now I know I changed these fields, so let's just change this. Okay, and then the other thing that I want to do now is generate the DBT docs. Okay, so this should finish in a second here. So far, we loaded the models. Oh, there's one more thing I forgot that I needed to do here. Remember, I had a lot of different items. I wanted to filter it. I forgot to put that there. So I want to filter it to that one item that we were looking at. And let's just make sure this runs again. So you can see down here, it's running just that single model. And the DBT docs also generated there. So while that builds, I'll trust that it'll finish. I'll go over here. And now let's look for gasoline, if I spell it right. So there is that gasoline model. And okay, this was generated before I made that change. So that YAML file, I changed after. Run that again here. Okay, so I think everything should be good now. Yeah, so that model refreshed. So while this is running again, I wanted to talk about the scheduling. So one thing that we thought about is when we're running these things, and let's just check it again. Okay, still didn't refresh. Okay, but when we're running this, let me go back up to the top level. DBT knows all the sources, right? All these green nodes are my sources. But DBT doesn't know how these sources got into the database. What if we were able to connect these back to the actual jobs that generated these and that loaded that data in Airbyte? So that's what we do. If I go back here, so we know that these jobs exist right there. These are my connections. So what we can do is we can actually tag these sources. So you would come in here, add a tag to this source. And then what you can do with that is then use those tags in the scheduling. We wanted to use Airflow, but we didn't want the complexity of having to write Python and everything. So instead, we have a YAML-based way of doing that. And in here, what you can see here is that we can select the models based on a tag. So here we would select the models that have this daily morning tag. And based on that, we go back and figure out how we extract and load that. So we have this Airbyte generator, and we take that Airbyte connection, figure out those, load those. And then once that's done, we run DBT with the same tag over here. And if I now go back over here, we'll see how that actually looks here, showing in the graph. So we have two steps. We have to extract and load, then we transform. And so extract and load, in this case, it's going to call these two sources, load them, and when they are done, then it'll run the transform. So you see, we use dbt's tagging to figure out the things that are getting loaded by Airbyte, and we load those, and then we trigger that. We wanted to use this because traditionally you want to do more. There's more complexity. First of all, you do want to unify these two steps. You don't want to load and independently transform at a different time, etc. You want there to be a connection between these two processes, but there may be processes after. So you may want to refresh some machine learning model, extract data to some tool, on and on, send data to some other downstream process, etc. So Airbyte and Airflow together allow us to create this flexibility. All right, so let's go now and actually look at this data. So let me see, I have this saved here. Okay, so this is the file that we created. Run this. There's our data with that date column that we created.
Nice.
Now here we can explore this. Let's just call it. Okay, so now we can explore this, and I want to change the visualization type. Let's just pick a line chart, and then we want the price to be our metric. So I'm going to run this, and there's our price. So we went from finding some data in the internet, loading it, transforming it, and visualizing. So I think that's all I had. I know it's a whirlwind tour of many things, but I'm open for any questions.
I do have a question I'm curious about. So using Snowflake as your data warehouse, what if someone wanted to use they have an account with BigQuery, right? What if you want to use BigQuery, another data warehouse? How does that work? If someone did start using Datacoves and they want to use a different data warehouse, would they be able to do that?
There is, all the tools that we're using here are compatible with any of the databases, right? So DBT will work with Snowflake, Redshift, and any number of connectors out there, right? I think even Databricks right now. The same thing with Airbyte and the same thing with Superset. So there's no restriction there. All of these things can run with any of that stuff. The downside is, and why we recommend Snowflake to people, is when you're getting to the CI/CD, the data ops, and the higher level things that we're showing here, it would just be a lot harder to do, and some of the things may be even impossible to do in certain cases. And so that's why it's not like you can't do it and it'll work just as well, because DBT and, like I said, all the tools work with all of these things. The only issue is just that it's that you don't have that opinionated approach that I mentioned. You don't get that much benefit, or you can't, you don't get all of that.
Definitely. Okay, thanks for answering that. I have more questions, but did you have any questions, Justin, that you want to ask as well?
So I actually have one from Alexander.
Yes.
From the chat. He asks, will Datacoves integrate with an existing DBT project?
Yes. At the end of the day, this is all being saved in a Git server. So Bitbucket, we've worked with Bitbucket, with GitLab, GitHub. It doesn't matter. So we've had customers who already had an existing project. So they had just, let's say, a DBT project, and we connected. This all works, and then we work with them to migrate to the structure as they're maturing the process. One other thing that I didn't show, by the way, since I'm here, is you see this underline here. We actually have SQL fluff linting, and so I forced this error just so that I could demonstrate that we also have an opinionated, approach. Like, you should be doing linting, and here are some rules that would be good. And obviously, you have access to all this stuff. There's nothing here that is hidden, nothing locking you into this platform. So if you wanted to see what my SQL fluff rules are, they're these, right? And then here's some other suggested rules. But that's another benefit of thinking about all of this. And one last thing I will do right here is, because we have Visual Studio Code, I can now say I want to lowercase all of this stuff, and there we go. So now we're consistent there. All right.
Nice. All right. So I do have another question. When you and the team were building Datacoves out as a tool, obviously with the load side of things, there's different tools and companies that you would consider, but what was it that ultimately brought you to use Airbyte? Was there any distinguishing factors that we brought to the table as opposed to any of our other competitors when it came down to, the decision?
Yeah. So I don't think that, I know that there's several tools in this space, but I quickly eliminated a few of them, and then just okay, it's this or that. I think one big factor was the fact that it's open source. I think, actually, I'll give you a real story. So the customer wanted to pull some data from Salesforce, but the connector wasn't working the way that they wanted. So they took that connector, forked it, made a modification, and used it. And they did that within a very short period of time. So having the source code to the connectors and the tool and all of that stuff, if you are capable, or you could even hire other people, you can move a lot faster. So you're not dependent on that provider to actually fix the problem for you, because they're the only ones who have the access to the code. And that was important to us. I think in all of this stuff, it's really, I subscribe to not having any vendor lock-ins. So like I said, that tool that I showed, Datacoves, it's an open source library that we created. Anyone can use it, just like we're using DBT and Airbyte. Like, to me, it's not locking you to anything. Our value should be how we integrate all of this stuff, how we enable you, how we manage that infrastructure for you, etc.
Nice. Yeah, open source definitely is the way to go, and there's a lot of power that can be seen and used with that. So I definitely love that aspect of things. Chris, do you have any other questions for Noel?
Yeah. So is this live now? Like anyone can just go to Datacoves website, start using it today? Is there a wait list? Is it in beta?
There's a wait list.
There's a
Yeah.
wait
Yeah.
list?
So we have two ways that we've been deploying this. We've done it what we consider on-prem. So in our customers' AWS or Azure account. And these are companies that are, like, one of our customers is a top 10 pharma company. And they had PII data and they wanted to have a lot more control. And so for those reasons, because it's all running in Kubernetes, it was easier for us to just deploy it in their account, and they have full control. They want to be able to have their own Docker registry and make sure that they scan anything that goes in their network, etc. So we've done that. And then we also have the SaaS version where we manage everything in our account. The SaaS version right now, we have a wait list, and that's how we're managing it, because we want to scale it thoughtfully and make sure that, if any issues come up, we're addressing them, and before we open it up to just free trials and grow it really quickly. So.
Awesome. And can, like, if I wanted to get in that front of that wait list, can I just send you a DM on Slack? I'm just joking.
If you know me, yeah. Just sign up. So there's a form you have to fill in, and on the datacoves.com website, and we'll let you in.
Excellent.
Cool. Noel, before we end the call here, is there anything else you wanted to go over? I don't have any questions on my end or anything from the chat. So any last words you want to leave us with?
Let's see what time. So it's, I guess we have half an hour, right? So I can show you one other thing.
Sure. Go for it.
We have time. All right, let me share my screen again. I was rushing through everything, but I'm like, well, we have time. Let's show you one thing. And this one thing is really thinking about security and how you manage your Snowflake roles. So I alluded to that, but let's show you how it actually works behind the scenes. And by the way, I don't know if you guys noticed, this thing did actually work. There's the query. And one other thing here, this is the actual query, the compiled query that was submitted to Snowflake. So if you wanted to, now you can just copy this and run it yourself in Snowflake. So talking about security, I mentioned how we break things down into multiple layers because we want to have everything very secure. So the way that we do this is we have a concept of object roles and then functional role. And the idea here is that object roles are very granular, and then we combine those, we bundle those up into roles that are functional roles that we then grant people. So if I open this, I'm down there now. Let me close all this stuff. Let me just go to the bottom here. So what we do here is we create roles by each object type. So schema roles, database roles. There's a database role. We have roles for warehouses. And so what this then allows us to do is, if the user uses this role by themselves, they can't do anything. They just have access to a warehouse. But if we bundle these things together, like we do up here, so I say an analyst needs access to all these databases, all of these schemas, and this warehouse. But this is still a base role because I want to differentiate different types of analysts. So now I can say I have my normal analyst that may have access to the entire region, so all the rows. So in Snowflake, we're using role level policies or masking policies, dynamic data masking. And so here, what we're saying is we start with that one, we give them access to all the views and tables, and then we give them access to all the rows. But what if I have an analyst that has PII? Well, it's the same as the one above, except they have an additional role that can unmask the data. What if I had an analyst in Germany? Well, it's almost the same as the first one, but instead of giving them access to all the rows, we're giving them access to only the German rows. And the PII, it's the unmasking of the data. So again, it's just another concept of keeping things granular so that you can roll them up. And more importantly, you can change some of this stuff only once. So if I say tomorrow I need analysts to have access to another database, I just add it one time in this template and everybody else gets it. And there's also a segregation of duties and a segregation where the highest level roles in Snowflake, an account admin or a sysadmin, they do not have access to actually query the data because we don't grant that. We only grant it here. So that was just one other thing.
Awesome. No, that's really important to point out. Thank you for sharing that. Thank you so much for joining us on this community call. If anyone missed the beginning of this call, this video will go live on YouTube by tomorrow or the following day, the latest. And again, if people want to find out more about Datacoves, we'll put the link in the description of on the YouTube video, and you can also see it on the community tab on Airbyte as well on our community call section. Thank you so much, Noel. We appreciate it. Thank you everyone for joining, and thank you also Justin for co-hosting this with me. I really appreciate that. We will see everyone in the next community call. Thank you, everyone.
Thank you.